Hello and welcome back to unit number 2 for Math 154. In this clip, we're going to look at another warm-up activity to review you and get you prepped and ready to go for unit number 2, which is linear and exponential growth. So let's take a look here at an algebra review for linear. Equation number 1, we've got y equals 5 plus 3x. And equation number 2, we've got y equals 10 minus 2x. So let's actually do number 1 first together. So go ahead right now and find the corresponding y values when the x value is as follows: 0, 1, 2, 3, and 4. Complete that on your paper right now. Pause the video and hit play when you're ready. Okay, so you should have had here values of y is 5. When x is 1, that's 3 times 1 is 3 plus 5 is 8. All right, when x is 2, 3 times 2 is 6 plus 5 is 11. Okay, when x is 3, 3 times 3 is 9 plus 5 is 14. And when x is 4, 3 times 4 is 12 plus 5 is 17. Okay, what I want you to do next is I want you to go ahead and make a graph of the ordered pairs. All right, so we're going to scale this thing here. So I'm going to say this is 0, 1, 2, 3, 4. And this will be 0 on the y-axis, and each mark will be count as 2. So 2, 4, 6, 8, 10, 12, let's see here, 14, 16, 18, and then 20. So go ahead and hit pause right now and plot your points. Okay, so you should have the point 0, 5, 1, 8. Oops. You should have 2, 11, so in the middle here. 3, 14. Make sure I'm on the right line. And then 4, 17. And you should notice that we make a nice linear path. So list out your y values right here. So go ahead and do that. So fairly simple: 5, 8, 11, 14, 17. All right, now think about this. What is the pattern of the rule? How do we get to the next input value? So take a moment to pause that and think about your rule. Okay, so what did you come up with for a rule? If you said add 3, you are correct. Now, what's our starting value, our initial value? When we're talking about the value, we're not talking about the x value, we're talking about the y here. So that's at 5. Okay, so thinking back to our equation, y equals 5 plus 3x, you'll notice the add 3 part, that's right here, and the initial or the starting value is here. So why does that work? That works because multiplication, which is what you see there in front of the x, 3 times x, is defined as repeated addition. Okay, so now that I have gone through and worked up the first one with you, I want you to go ahead and pause your video and see what, and then now go ahead and complete equation number 2 the whole way through and see what you can come up with for an answer. When you're done, come back and check in. Well, welcome back to the video, and you should notice here all my answers are filled in, and I'd like you to go ahead and check your answers now. So go ahead and put a pause on the video if you need to and see if you have answers that match my answers. Okay, so welcome back. So we're now going to move to page 2 here, equation 3 and 4. So I'll model with equation number 3 for you, just like I did on the front page. So we need to go ahead and fill in the table. So we have 3 times 2 to the x. So that's 3 times 2, whoops, not 20. Let's make that a 2. 3 times 2 to the 0. Remember, anything to the 0 is 1. So 2 to the 1, 2 to the 0 is 1, and 1 times 3 is 3. So now I have 3 times 2 to the first. Oh man, I did it again. All right. So remember, use rules of exponents here. 2 to the first is going to be 2. And then 2 times 3 is 6. Here we have 3 times 2 squared. 2 squared is 4, and 4 times 3 is 12. Here we have 3 times 3 squared. 3 squared is 9, and then 9 times 3 is 18. And then I have 3 times 4 squared. 4 squared is 16. 16 times 3 is 48. All right, let's go ahead and make a graph here. So x values, 0, I'll make this a 1, 2, 3, and 4. Now I have to go from 0 up to 48. So I think I'll count by 5s here. That should work out well. 5, 10, 15, 20, 25, let's see here, 30, 35, yes, we're just there, 45, and then 50. Plotting up my points. Now we're going to have to do a little bit more estimating. So here we are at 0, 3. Right. Then we're at the point 1, 6. That's like right here. All right. Now I have the point 2, 12. So up right there. Oops. Get that thing to stop doing that. Okay. Then we have 3, 18. So we're here, right below the 20. And then we're at 4, 48. So we're way up here. So if you kind of notice, this doesn't have a linear pattern to it. This is more of a curve. Okay, that's not really a good line. So let me try and redo that curve there. All right, so this is more of a curved looking graph. So more like that. So you'll notice it kind of looks like it's linear, but it's really not. So list the y values. So we have 3, 6, 12, 24, 48. What's the pattern? So how did I go from 3 to 6, 6 to 12, 12 to 24? We can kind of see here that we're doubling or multiplying by 2. The starting value here, that was 3. All right, so now in terms of our equation, we had y equals 3 times 2 to the x. So here's the multiply by 2 part. Here's your starting value of 3. So here in terms of the exponents, so exponents here represent repeated multiplication. So before on the earlier page, multiplication was repeated addition, exponents are repeated multiplication. All right, so go ahead right now, pause the video, and you're going to work all the way through equation number 4. So welcome back. I hope you take a moment now to go ahead and check your answers here on equation number 4. And again, notice this time we kind of have that curved pattern, but we're going down. Okay, so we're going to go down here. And if you notice the pattern of the rule, there's 2 ways you could represent that. You could say we're dividing by 2, or that we're multiplying by 1/2. So I would have probably said multiply by 1/2 because the 0.5 is this is the multiply by the 1/2. And then here's your initial value of 12, okay? Well, now that you're all warmed up and ready for unit number 2, let's go ahead and dive into the content. Thanks for watching.